Okay, hello everybody. I hope you are having a wonderful day so far. I'm just gonna double check the sound here to make sure that it's actually working. Give me 2 seconds because my internet is having a moment today. Okay, so welcome everybody. Hope you're having a wonderful day so far. And what we're going to talk about today, unless anybody has any other questions, which if you do, just let me know. Feel free to drop them in the chat. Um, but today's lesson, I'll say, is actually going to be about what you should be doing over the summer to figure everything out. Okay, so again, if anyone has any questions, you're more than welcome to ask them in the chat. Give me 1 second here. Okay. So, first of all, for those of you who are just wrapping up grade 9, I want to say congratulations on finishing your first year of high school. I think that's really awesome. I know that this did not turn out to be the year that everybody was envisioning, but I do want to say that for those of you who have been coming on here and asking questions and sticking around, you guys have been doing a really awesome job. So, what I would like to get started with today is really just to give you guys a framework for what you should be working on for next year. Because obviously, we covered a lot of different topics in grade 9 math, but realistically, not all of them really matter. Not all of those topics are things that you're going to need in the future, whereas some of them are very, very important. So, given that information, I think it's very, very good for those of you who have extra time this summer to practice certain skills so that you are not going back to grade 10 math with less memory of what it is that you need. Okay, so without further ado, we're going to discuss what it is that we want to practice over the summer. So I'm going to first create like a little list here for you guys, and then we can do some examples, okay? So first and foremost, while this isn't explicitly part of the grade 9 curriculum, I do strongly recommend that if you have trouble understanding integers, so the addition and subtraction of integers, oh, I should probably get my pen working. That is a very important topic. And in particular, I would say if you have trouble understanding integers with fractions, that's going to be the number one thing. Up next, and again, I'm going to go through examples with these, and if anyone has any questions, you can absolutely let me know. I first just want to kind of create a list so that if anyone has questions about a particular topic, we can narrow in on that right away. Okay, my other big recommendation is going to be making sure that you understand BEDMAS. And I know this sounds like something silly because obviously we've been doing BEDMAS for a couple of years, But I find that in general, kids, as they get out of grade 9 and into grade 10, tend to have some misgivings, I guess, or just struggles with bed mass in general. So that's a hugely important piece that I think everybody should be focusing on. And within that same vein, kind of, not really, but a little bit, is the concept of algebra. So these three things are skills that you learned before grade 9 that are going to come up over and over again. I would say these are kind of at the core of all math skills for the rest of high school math and beyond, especially if you're going to be taking things like calculus in university. It's really, really important. Okay, great. Let me erase that star. I'm not loving it. Not loving it. Okay, so those are kind of those three main things. Now, outside of this, we're going to be talking about the things that you learned in grade 9. So, first and foremost, I think what we really need to focus on is understanding the exponent laws. So, definitely, if you struggled with the exponent laws, especially as they got more complex and you had to do more intense questions on the exponent laws, I would highly recommend going back and practicing these, especially the complex ones. Okay. So, again, just as a refresher here for anyone who might not have seen this lesson with us, you want to practice the product rule and quotient rule, as well as power rule. And kind of in these order, you want to practice them. So these aren't going to directly affect you in grade 10 so much as they are in grade 11. But the reason they're important is because when you're multiplying polynomials, you do need to have a good understanding of the exponent laws. And same thing with dividing polynomials, which is a part of the grade 10 curriculum on some level. Okay, so, and then also, where'd it go? Exponent 0. And finally, negative powers. Which I hope you guys can actually see that. Oh, great. Okay. Perfect. So if you're just writing that down, just let me know if you have any questions specifically about that. Okay. Great. So other than that, I think we also really, really want to make sure that we're understanding polynomials. So just going to put a little thingamabob here. So when I mean polynomials, things like this, 4x times negative 2x plus 3 minus negative 4x plus 2. Understanding these types of questions and how to manipulate these types of questions is incredibly important. And if you struggled with this year at all, I implore you, please practice this before you go to grade 10, because grade 10 is so, so heavily based on this concept that it's not even funny. So if you struggled with this year, I beg of you, go back, practice it, whatever you need to do. If you need to seek out help for it, do so, because it really is something that has to be understood. So when we talk about polynomials, the topics that I think are very important, definitely the terminology, monomial, trinomial, polynomial, binomial, stuff like that. Terminology. And we've got adding and subtracting them, kind of like the one that I showed you here. Then we've also got multiplying and dividing. And again, I know that this is kind of the boring stuff for you guys, but first we have to understand what we need to know. And then if anyone has questions, we can cover that. And then what I think is one of the most important skills is collecting like terms and simplifying polynomials. So that's really, really important, you guys. And if it's something that you struggled with, that's okay. It's not a bad thing to have struggled in life. It's just about addressing the areas that need focus. And the summertime is the perfect time to do that because we don't know what school is going to look like for you guys next year. I don't want you guys to be falling behind before you even get started in high school. Because I think that I truly believe that after years of tutoring myself and after years of running this tutoring company, I know for a fact that most of the people who think that they're bad at math are not bad at math. It's most often that there was one or two issues that never got addressed because, we all have that fear of putting up our hand in class. I get it. I've been there. Um, but that's the beautiful thing about stuff like this and using the internet or getting a tutor, whatever you want to do to help yourself fill in those gaps that you might have felt during the school year. So that's kind of why I wanted to do this session today, because even though I know that the school year is pretty much over for everyone, for people who want to know what it is that you need to know, definitely a good way to address what it is. So, and then last but not least, the distributive property. And again, if you were just to type in each of these like points and type into Google polynomials, the distributive property worksheet, there's a ton of stuff. There's a ton of stuff, okay? Okay, great. So that's pretty much all of it for polynomials. Let's just this, this. Not my best lines, but I'm trying. Okay. So another thing that I think is really, really important is understanding how to solve algebra with fractions. You know how I was talking about integers with fractions? It's also really important to understand algebra with fractions. And we've done a lot of that here. So if you want to go back and watch some of our old videos from previous weeks of the live stream, we've covered this quite a few times. But if anyone has questions today, you're more than welcome to drop them in the chat. Okay. And then let me just double check my list here. Oh, so in the analytic wow, my brain. Analytic geometry unit, which is the unit where you have linear relations. You want to cover a couple things. First of all, don't forget the equation of a straight line. Of a straight line is what I'm trying to write. And definitely don't forget how to graph it. So you can definitely practice that over the summer a little bit. Okay. So you guys, out of everything you learned in grade 9 math, obviously there are other little things that will come up again. You want to make sure you're remembering your times tables. You want to make sure all of those little pieces that are part of the computational skills in math are there. But other than that, these are really the core skills I highly, highly recommend that you keep practicing before next year because they will come up again. Um, not to do too much of a plug, but one of our programs, which is the pre-teaching program, actually makes sure that students understand all of these before we pre-teach you anything else. Because if we were, so a lot of students that are scholarly elite students come to us to pre-learn the next year's math class, which is awesome. The thing is that that pre-teaching you next year's math class is never going to happen unless we make sure that these core skills are in place, because without these core skills, next year's math class doesn't really make sense, and it's not going to be as effective to learn it without understanding all of these. Okay. Alrighty, guys. So if anybody has any questions, I'll give you guys a couple seconds to just drop that in the chat if you'd like. Okay. So we're going to do a couple examples of each of the things here. And then if we get through that early, then we're just going to wrap up early today before the grade 10 class. Okay, so first and foremost, let's talk about exponent laws. We want to take a look at each piece here. So product rule, again, I'm not going to get too in depth because if we were to get in depth, then it would take way longer than an hour to cover everything. A product rule is when you have two of the same base being multiplied by each other and you add their exponents. So if you had like x to the power of 1 times x to the power of 5, that would come together to become x to the power of 6. Then we have our quotient rule, where we would have something being divided by the same base. So we have like y to the power of 10 divided by y to the power of 6. And then that's going to become y to the power of 10 minus 6. And it becomes y to the power of 4. Okay, power rule. Again, I'm just skimming through these for anyone who might be joining us. I'm just skimming through these so that everyone can kind of see what they're about. We did cover these in other weeks, and I've done full lessons on all of these topics. So you can definitely go back, watch our old videos to kind of get, basically if you watch all of the freemathhelp.ca videos that are on our YouTube channel, you're getting the entire grade 9 curriculum. So definitely a good thing to do right before the school year next year if you're interested. Okay, power rule. So power rule is when you have a base inside of brackets. So let's say we had like, um, y to the power of 2, and then that's being power, like it has an exponent of 3, for example. And what happens here is we have to multiply these exponents. So it becomes y to the power of 2 times 3, and that equals y to the power of 6. Alrighty. Then we have exponent 0, which I feel like could be a cool movie name. Exponent 0. The word 0 is just a cool word. Okay. So anything to the exponent 0, it doesn't matter what the base is. It could literally be, apples to the power of 0. The answer is always going to be 1. So if I had x to the power of 0, the answer is going to be 1. If I had 55 to the power of 0, the answer is 1. Every single time, no matter what, if it's to the power of 0, the answer is 1, you guys. Okay. And then finally, we've got negative powers, which sounds like something out of Harry Potter. Negative powers. No? But that's okay. So negative powers, anytime something is to an exponent that is negative, so for example, y to the negative 3, that just means that y is on the wrong side of a fraction. So if I had y, technically, let me get rid of that dot. Good. So y to the power of negative 3. So what's going to happen here is that technically y to the negative 3 is on a fraction like this. And it's not that I'm flipping the fraction. I'm literally just putting y on the correct side of the fraction. So I'm going to show you another example to show you what I mean about the fact that they're not flipping the fractions. So if I had 5x to the power of negative 2 over y, the only thing I'm moving is the x. So it's going to look like this: 5 over x to the power of 2y. Nothing else moved, only the x. Okay, that's the power of negative powers. Okay, let's go back and see what we're going to do next. So polynomials, we kind of touched on this a little bit, but let's kind of go over what I mean for each of the things. So polynomials, when I mean terminology and degree, if I had a, like, okay, well, let's just open this up. If I had terminology. So for example, something like this, 5x, that's a monomial because there's only one degree term in this with unknowns. So let's say I had, 5x squared plus 2. That's a binomial because there's two different things there. And if I had 5x to the power of 2 plus x plus 9, that is a trinomial. Okay. Wonderful. So that's our terminology. Obviously, these are all, except for the monomials technically, but these are all types of polynomials basically. And when I talk about adding and subtracting, so let's say I had 5x times 2x plus 1 minus negative 2x plus 7. This is what I mean by adding and subtracting, this type of thing. So this is obviously a subtraction sequence basically, and it's important to understand first of all that we need to use BEDMAS in situations like this. So first and foremost, I want to do my multiplication. So here I have 5x. I need to multiply this in to here and to here. So 5x times 2x is going to be 10x squared. Remember, that's important because of our exponent laws. And then 5x times 1, or positive 1, is going to be positive 5x. So here is where it gets tricky for a lot of kids. And so I always like to go over this as much as we can with all of my students, or when I used to have students. I don't tutor anymore. But for here, this is a negative. Another way of saying this is negative 1. So really, this is like saying negative 1 times negative 2x times positive 7. So let's go ahead and do that. We get positive 2x minus 7. Now we just need to collect like terms. So we get 10x squared plus 7x minus 7. Okay. And then for multiplying, we've got, let's say we kind of did so up here already, but like, let's say we had 10x squared times x plus 5. Then we're going to get 10 x cubed plus 50 x squared. So let's say we're dividing. And we've got 50x cubed divided by 10x squared. Well, this is where our knowledge of a couple things comes in handy. First of all, we want to reduce. And also we want to use our exponent laws. So technically this is going to be 5x. Actually, make that an equal sign. So that's because we did x to the power of 3 divided by x to the power of 2, which obviously gives us x, and then 50 divided by 10. Okay. So we covered a lot of these things here. Algebra with fractions we're going to cover now as well. So we look here. And this is a recent lesson that I did. I don't remember if it was last week or the week before, but we did cover it. So let's say, and I'm just going to make this up off the top of my head, so bear with me, but let's say we did like 2 over 5x plus 37 equals 20. And actually, no, we'll make it 20x over 2. So first things first, I want to create a common, or realize what my common kind of denominator is. And in this case, it's going to be 10. So I'm going to multiply everything by 10 here, the whole shebang. And let's see what happens to that. And again, I'm just kind of going through these a little bit quicker, but we typically in other lessons we did the whole lesson, so you can feel free to go ahead there and take a look, okay? And again, if you're just joining us and you have questions other than the stuff I'm covering, excuse me. Sorry about that, guys. If you have questions other than the stuff I'm covering, you're more than welcome to ask them in the chat. Okay, so now we're going to ask ourselves, how many times, sorry guys, how many times does 5 go into 10? So 10 divided by 5 is 2, so we're just going to be left with 2 on the outside here. And then we've got times 2x, and then 10 times 37, which should give us 370. And then 10 divided by 2 is going to be 5, so those kind of cancel each other out. And leaves us with 5 there, and we get 20x. Great. And now, not what I was trying to do. Now we just need to isolate. Okay, so as we isolate, we're going to first have to do that multiplication around here. So we get 4x plus 370 equals 100x. And then we need to collect like terms. So let's put all the like terms on the one side and all the others on the other. So I've got 370 equals 100x minus 4x, because 4 was positive on this side and I moved it over. Wonderful. So then I'm left with 370 equals 96x. And now I want to isolate for x, so I'm just going to divide off 96. Perfect. So 370 and 90 is not going to be perfectly divided by 96, obviously. So what I'm going to want to do is reduce so that's going to cancel. And we get, basically I'm going to divide this by 2 for each of them and see where that gets us. So I get 185 And then 96 divided by 2, 48. Alrighty. And then I actually don't think that can be further reduced. I could be wrong, but no, not without making decimals. So we're just going to leave it there. Okay. And last but not least, basically the last thing with the analytic geometry is just remembering a couple key factors. So remember that we have y equals mx plus b. That's one way to describe a line. This tells us a couple key factors. This m term is our slope. The b term is our y-intercept. And then this x term is just a x value, y term is just a y value. Another way of writing this type of equation is a of x plus by plus c equals 0. That's the standard form. So just remember that this is important because obviously next year you're going to need to know how to graph these. So because basically at the end of the day, we're going to be learning next year how to find their points of intersection, which I know some of you did in grade 9, but most people don't. And that's that. Wonderful. Okay. So that's pretty much the gist of what we know is going to be important for next year. I'm going to wait here for about a minute in case anybody has any questions about anything. But if not, my friends, that means that we are wrapping up the grade 9 class for freemathhelp.ca. I want to thank you all so much for coming back week after week and joining and learning with us. If anyone has questions, you're more than welcome to submit them through our website, scholarlyelite.com. We are here to help. We offer online and in-home tutoring if anyone needs help over the summer or wants to pre-learn grade 10 math over the summer. But until next year, when you guys get started again in September, I wish you an amazing summer. I hope you're staying safe out there. I hope you're well. And as always, if you ever need someone to talk to, there's also kidshelpphone.ca. There's amazing, amazing counselors there, and you're never alone. Okay. For math help, you've got us. For life help, you've got kidshelpphone.ca. Very different things, but both resources you can use. Okay. I wish you all an amazing summer, and I will be back on here at 2 p.m. for the grade 10 class. So if you have questions that you think of by then, feel free to join the grade 10 class. I'm happy to answer them quickly during that class session. But other than that, have an awesome day, you guys, and have an amazing summer. I hope you really do have a summer that just makes up for how this school year went, and I hope that you stay safe and have a good one. Okay? Thank you, guys. Have an awesome day, and I'll see you all hopefully in the next session if you join us, if we ever do freemathhelp.ca again. Have a good one. Okay. Bless you guys. Have a good one. Bye.